Hello and welcome to Utkarsh Minds Python for Data Science. Today we will see paired test on scale data. So I will start my Jupyter notebook Colab and open a new notebook. Then I will name this notebook as paired scale and then I will connect. So first I will, if I get an error like this, then terminate other sessions and connect. So import, we will need pandas, we will need numpy, and we will need matplotlib.pyplot as plt. These three things we will need in our data set. Suppose we are interviewing some individuals. Let us say we are interviewing 50 individuals and we are noting their weight before they go for a particular gym. So I am creating some random responses of some number of individuals. So this is random data which is response of the people before they go to a particular event and then after the particular event. So I will say this is 30 and this is 20. So I am randomly generating some data and I am creating all this data in the form of a data frame. And now that the data frame is created, I am showing you what is the data frame before and after. So that is done. Now our job is to analyze this data. First I will calculate the statistics like mean and standard deviation. So the mean is 70 here, before the average weight is 70 and after the average weight is 27. So just by looking at the data, it seems that there is a change. One more thing that we can do is create a histogram of the data. So we will visualize the data from the help of a histogram. We will have two subplots in one column and the figure size will be large enough for visualizing. Then the first subplot, I will just create a histogram. This will be of the data before. We will have some 10 bins in that histogram. We will have a color as blue and we will have edge color as black. Again we will create one more histogram. This time it will be for after and it will be red. And then with the tight layout we will ensure that the histograms are close to each other and visualizing. So here you can see the distribution. The ranges are different. This is -40 to 80 whereas this is 50 to 90. So they cannot be compared, they are not on the same scales. Next we will apply our SciPy stats method The test that we will apply is known as the student t-test dependent sample, or it is also called as the t-test underscore REL, related samples t-test. You can read the description of the test here. It is quite easy to execute. We have written like this, and then data, here we will write before, and then data, here we will write after, and run the test. So it will generate a p value which is very small, which means the null hypothesis is rejected, and we can say that the event had an effect. The weights before and the weights after the event were different. The effect size for this particular you can say test, that is the related samples t-test, is known as Cohen D. To calculate the Cohen D, we will need to install a package known as researchpy. So pip install researchpy. Then in this researchpy, from researchpy, there is a t-test, and then this t-test we can implement on our data by passing before, and then we can say after, and equal variance. It is better to write the equal variance as false, and paired, since this is a paired test, then it will be true. We will have to wait till this py package, researchpy package, is downloaded. And from this we have got the results positive. All this data is it is mean before, mean after, and we have got some results here: rank, Biceral R, and Pearson R. Just I will have to check again RPT test. Maybe we executed the wrong test. So I am making a small change here, re-executing the test. Okay, we have got the same result, and from this the Cohen D. Okay, so the mistake was that equal variance has to be true. Running the test again, now it will give us the correct answer. You also should set the equal variance parameter here as true. And now it has given us the Cohen's D value as 1.66. So this is my Cohen D. From this, to get the final Cohen's D, we will have to apply a small calculation. I will call it the capital D. So we take D and we multiply it with the square root of 2 to get the final effect size, which is 2.37. With this effect size, we have several different levels, so we will implement an if-else function to see how we can get the interpretation of this 2.37. To interpret this, we have this table. If the D is less than 0.2, then it is very weak, and so on. We are getting 2.37, so it is an extremely strong effect. So in this way, we have applied the method on data, and we have proved that there is a difference in before and after weight because of the event, and that difference is a extremely strong difference. Although we have used dummy data, but you can easily use any other data that you want. So go ahead and apply this on other data sets. Thank you for watching the video and good luck.